Happy Monday, 6th grade. We're continuing on with Chapter 8 in Science. Today we're going to talk about earthquakes and volcanoes and what causes the earthquakes and volcanoes, and then how we can try to predict them and stay safe from them is what we'll talk about tomorrow. So you got lesson 4 here. It says, what causes earthquakes and volcanoes? The summary statement says, earthquakes are caused by the sudden shifting of rock as tectonic plates shift positions. Volcanoes occur when magma from the mantle either flows or explodes through the crust. So guys, lots of times what they're getting at with this statement is there's two different types of volcanoes. We usually picture the mountain that erupts and spews it everywhere. Mount Vesuvius would be an example of that. Mount St. Helens from the last chapter would be an example of it. But anytime there's magma flowing from the crust, Hawaii would be an example of this. It's a non-stop volcano in Hawaii. It's not spewing it hundreds and hundreds of feet into the air, guys. It's just flowing out and making more land. We're going to start with earthquakes first, and from there we'll get into volcanoes. It says plate movement takes place so slowly that you can't see or feel it. In fact, some plates don't move for many years. So number one, you can't feel it. Some don't move for years, guys. Now remember, we were talking at the beginning of this chapter on how they're moving about 2 centimeters a year, and it's pretty steady. That's not true with all of them. Here's why. Jagged rock edges in the lithosphere sometimes stop the movement. Over time, pressure builds up until suddenly the pressure is too strong. The rocks lurch forward, the earth crust shakes, and an earthquake has happened. Okay, so this is an earthquake. So sometimes the way to picture this, guys, is just if I had 2 boards covered in sandpaper, so they're really rough, and I push them together, they don't just slide past each other anymore because of the sandpaper. So I have to start to put a lot of force, and then as soon as I get a lot of force, then boom, there it goes and it takes off. In one of the previous videos, I talked about starting to bend a ruler and how you have those opposing forces, and then all of a sudden when there's enough, that ruler snaps and away it goes. So that's what an earthquake is. Now let's learn a few more terms. Earthquakes cause damage when the pressure that builds up along a fault is suddenly released. The underground point where an earthquake occurs is called the focus. So the focus is the underground point, guys. Earthquakes never occur at the surface of the earth. They always occur miles underground. So if I'm 20 miles underground where the earthquake is, that's the focus. The point on Earth's surface directly over that focus is called the epicenter. This is what we're usually interested in, guys, because the epicenter is where people live. We're on Earth's surface. So the epicenter is directly over Earth's over the focus. So inside of Earth, on the surface of the Earth. The energy from an earthquake is carried by waves. Number 5, the waves spread out from the focus and from the epicenter. So I don't really like that sentence, guys, because the waves spread out from the focus, because that's where the earthquake occurred. It's going to hit the epicenter, but it's not like there's 2 different points where an earthquake happens. It happens at the focus. Some waves cause the ground to move back and forth. Number 5 in your notes, second blank, and some cause the ground to move up and down or in a circular motion. So we would say it's an up and down as it goes through that. So think of a wave going up and down and think of a wave shaking it side to side. Okay, before I move on to the next thing, guys, you just got a few things. Number 1, the likelihood of an earthquake happening. You can see Wisconsin, very, very low chance of an earthquake happening because we're in the dead center of this plate. Having said that, guys, there have been recorded earthquakes in Wisconsin. Barely can feel them ever. Obviously, California is a hot spot for earthquakes because it belongs along the plate tectonics. Here's something else that I think is interesting that might surprise some of you. Scientists study the vibration within Earth's crust to learn about earthquakes. This map shows the earthquake activity in California in a 24-hour period. So if I would have asked you guys, were there any earthquakes yesterday? Most of us would have said absolutely not. There were no earthquakes even in all of America yesterday. And reality is, guys, there were 20 of them in California alone. Scientists actually like that. A lot of little earthquakes means no big ones. Big ones are the ones you and I hear about on the news because buildings are damaged and people might lose their lives. These small little tremors that are detected by their machines or their devices, don't cause much damage. We just detect those things with the thing. So lots of small ones, but guys, what they're noticing is the earthquakes are happening all the time. Okay, as the waves spread out, they lose energy. So you got number 6 in your notes. The possibility of earthquake damage, therefore, is greatest the closest to the epicenter. Why we use the word epicenter here and not focus, guys, is we're not going to have damage at the focus because nobody lives in the focus. It's 20 miles, 10 miles, 30 miles inside of Earth. Where are we going to have damage? Where humans live. So that's why they use the word epicenter. Most damage often occurs to nearby construction, such as highway and buildings. Almost all of the major earthquakes in the United States occur in either California or Alaska. These states are on plate boundary between the Pacific Plate and the North American Plate. Most earthquakes take place near the edges of plates. So you got California and Alaska because they're on plate boundaries. The map on page 228, which I just showed you, shows the earthquake hazard, how likely an area is to have an earthquake. For different parts of the United States, as you can see, the highest levels are along the west coast. The strength of an earthquake is given as its magnitude. An earthquake magnitude scale is a series of numbers. The numbers show the total amount of energy released. Okay, so the magnitude is the measure of the strength of the earthquake. Now we're going to use magnitude with other words, guys, but in this chapter, it's the strength of the earthquake. Okay, the Richter scale is one such scale. So we use the Richter scale to measure the total energy released by an earthquake. Here's how the Richter scale works, though. The Richter scale, each increase of 1 on the Richter scale indicates about 31 times more energy. So if I have a Richter scale of 1, okay, that's the energy. If I go to a Richter scale of 2, that's not 2 times more strong, it's 31 times more strong. I go up to a Richter scale of 3, that's not times 3, it's now times 31 times 31, so over 900 times the strength of a 1. If I go again to 4, I take it times 30 again. Now you're talking 2,700 times the strength. So each increase of a number, guys, is way more energy. The table shows the magnitudes of some earthquakes and the number of people killed. Notice that the magnitude of an earthquake doesn't always indicate how much damage will result. Why is that? Because of the effect of the earthquake depends on a number of factors. 1, the size of the earthquake, the distance from the epicenter, the kind of rock in an area, and the types of buildings in that area. So guys, you're filling in number 10 here. You got the size and strength of an earthquake. So in general, the higher the magnitude, the more damage. Distance from the focus. The farther into the earth, the less damage. So if the focus is 10 miles from the surface, more damage. 40 miles from the surface, less damage. 100 miles from the surface, even less damage, okay? Third type is the type of rock. So what are you building it on? Am I solid rock that can not shake that much? Are we loose sand where the buildings might collapse? The type of material, the kind of rock in the area plays a major one. And the last one is the type of buildings. Okay, in America, guys, we're pretty good at building strong buildings. A number of years ago, Haiti got hit with an earthquake. It just leveled Haiti. Why? Well, Haiti is a very poor country, guys. So a lot of not well-built buildings all factor into that. So the other thing that I think comes down with this is you're looking at this one, guys. You can see the strongest earthquake up here of 7.6 didn't kill that many. The 6.6 killed 30,000. There's one more thing that obviously factors in there, and that's where is the distance. We have an earthquake that occurs in the middle of Montana, let's say, where there's not very many people. Well, okay, not that many people are going to die. You have an earthquake that hits Los Angeles, California, where there's a ton of people and bridges collapse. You obviously have a greater chance of life. So I look at this chart and just looking at this, guys, in Iran, this might have been in the middle of a city. Obviously, a lot of people are going to die. We have a strong earthquake in Mexico, but we're out in the middle of the country, not that many people out there to die. So you got the in general of how we have and measure earthquakes. Okay, volcanoes. Picture a tall cone-shaped mountain with thick, glowing matter spewing from it. The picture in your mind is a volcano. A volcano is the opening in the surface of one of Earth's plates through which magma rises. Okay, so it's in Earth's plate and magma's coming out of it. Like earthquakes, most volcanoes occur near plate boundaries. The theory of plate tectonics explains why. When one plate sinks beneath another at a plate boundary, the sinking crust melts into magma. Pressure can build up from gases trapped in magma, somewhat like the pressure that builds up when you shake a carbonated beverage. So if I say shake a 2 liter of soda and then open the cap, we know it explodes everywhere. If the crust on top of this overlying plate can no longer withstand the pressure, magma explodes through it as a volcano. Magma that reaches the surface is called lava. So to fill in these blanks, magma is molten rock that is inside the earth still. When it reaches the surface, when it's outside, then it's called lava. So molten rock outside the earth is lava. Okay, so keep those two things straight. Volcanoes are more common than you may think. That's because you never hear about most volcanoes. They take place where plate boundaries are moving away from each other on the ocean floor. The Mid-Atlantic Ridge, guys, is a great example of that. Magma quietly flows out onto the ocean floor and new crust forms and is cooled into lava. Okay, so down here, I wrote many volcanoes are on the ocean floor, so we never hear about them. Hawaii is a great example, guys. For years, Hawaii was erupting, but it was literally in the middle of the Pacific Ocean, guys, miles underneath the water. So it's forming land, but it hasn't broke the surface yet. Now, today, Hawaii is above the surface, and so we can see that stuff. But that's going on all kinds of places where volcanoes are erupting, but we never see it because it's 2 miles underneath the ocean. All right, I'm going to go through your letters now. A, the ash cloud. So you can see the thing up here. Tiny bits of rock spew into the air during an eruption, forming a thick cloud. This can block out sunlight and cool temperatures. A crater is a steep-sided depression at the top of a volcano. Craters can form during an eruption or if the rim of a volcano collapses. So lots of times, guys, when a volcano erupts and blows off, this will then collapse in because there's no magma there to take its spot. Another thing to notice with this one is so often we think volcanoes are made to erupt straight up the middle of it. Not always true, guys. Mount St. Helens was an example of this. It bulged out the side and erupted out the side of it. Letter C, hot spots. Volcanoes are common in Hawaii, even though the islands are not near a plate boundary. Hawaii is on a hot spot, an area of ongoing volcanic activity. So what they think about volcanoes, guys, so the state of Hawaii, is that the plate where Hawaii is actually a little bit thinner. So normally we talked about the continental plate or the ocean plate being 20 kilometers thick. They think it's a lot thinner as Hawaii. So as Hawaii moves, as those plates are slowly moving, it can spew forward and you're constantly getting these things. So you notice, not an explosion, just flowing out of the earth and then being cooled, and then it flows eventually, it hits the ocean and it hardens into rock. So Hawaii is literally getting bigger. D, a caldera is a crater. Why is it different? Because this one's really big. It has to be at least 1.6 kilometers wide. So that's like a mile wide, guys. So if you have a really big one, we call it a caldera. Smaller, we call it a crater. A lake may form in a caldera. This 9.6 kilometer wide crater lake in Oregon formed in a caldera of the Cascade Mountain Range. So years ago, a volcano erupted, fell in, fills up with rainwater, and you have a beautiful, beautiful lake. Crater Lake you can see crystal clear is because you're up on top of a mountain, guys. There's no pollution to it. So it's just a gorgeous, gorgeous lake. Okay, so I wrote down large crater. Many times it'll form into a lake. And a couple more. E, flows of lava spill out onto the nearby ground, forming new crust. Basalt is a volcanic rock. So spills out onto the ground. Basalt is one type of rock. We'll talk about that coming up in the next chapter. Different types of rocks and minerals out there and where they come from. Volcanic is one of those. And a geyser, magma trapped in the lithosphere, can heat underground water. In some places, the steam then spews from the crust. So superheated steam spews from the crust. Extra credit, can you name the most famous geyser in America? It is Old Faithful in Yellowstone National Park. That's where we'll stop today, guys. We'll talk tomorrow a little bit about how we try to stay safe and how we try to predict these two natural disasters so that they don't cause damage or harm. Okay, have a blessed day.